There is something buried beneath the moon that should not be there. It lies beneath the largest impact crater in the solar system, a mass so dense that it is deforming the lunar surface by more than half a mile. We know it is there because the moon's gravity gives it away, and in 2019, China landed directly above it. What China uncovered does not align with existing models of the moon's interior. So in this video, we are looking at what China actually found on the dark side of the moon. The other face of the moon, the one we cannot see from Earth, is called the far side. Some people call it the dark side, but that is a bit misleading. The term does not refer to darkness in the sense of light. It refers to mystery because we cannot see it. We cannot communicate with it. Radio signals travel in straight lines. When you send a signal from Earth to a spacecraft on the far side of the moon, that signal is blocked by 2,000 kilometers of solid rock. There is no way around it. The moon itself acts as a barrier. This is why no spacecraft had ever landed on the far side until 2019. It is not that we lacked the technology to get there. It is that we lacked the ability to control a spacecraft once it arrived. The solution is a relay satellite. In 2018, China launched Queqiao, which means Magpie Bridge. The name comes from a Chinese folktale about two lovers separated by the Milky Way. Once a year, magpies form a bridge with their wings, allowing the lovers to reunite. Queqiao was designed to do something similar for spacecraft and Earth. The satellite does not orbit the moon. Instead, it sits at a special point in space called the Earth-Moon L2 Lagrange Point. This is a location about 65,000 kilometers beyond the moon where the gravitational forces of Earth and the moon balance out. A satellite placed there can see both Earth and the far side of the moon at the same time. The idea is not new. It was first proposed in 1966 by Robert Farquhar for the Apollo program, but no relay satellite was ever launched for Apollo. The far side remained unexplored. China was the first to make it work. On May 20, 2018, Queqiao launched from the Xichang Satellite Launch Center. It took 24 days to reach L2 using a gravity assist at the moon to save fuel. On June 14th, it entered its final orbit and became the first lunar relay satellite ever placed at that location. Everything was ready. 7 months later, Chang'e began its descent. The landing site was the von Kármán crater, located inside the much larger South Pole-Aitken Basin. The South Pole-Aitken Basin is not just large, it is the largest confirmed impact structure in the solar system. It is roughly 2,500 kilometers in diameter. That is about the distance from Texas to Washington, D.C. The crater is so big that you cannot see all of it at once, even from orbit. It formed approximately 4 billion years ago when a massive object, possibly the size of a small planet, collided with the moon. The impact was so violent that it may have excavated material from depths as great as 200 kilometers below the surface. Scientists believe the collision might have exposed the moon's mantle, the layer between the crust and the core. If true, this would make the basin one of the best natural laboratories for studying the moon's interior composition. But there is something else down there. In 2019, researchers at Baylor University analyzed data from NASA's Gravity Recovery and Interior Laboratory mission, known as GRAIL, and the mission used two spacecraft orbiting the moon to measure subtle changes in its gravitational field. When they combined that data with topography measurements from the Lunar Reconnaissance Orbiter, they found something unexpected. Deep beneath the floor of the South Pole-Aitken Basin, there is a massive concentration of material. The anomaly is so dense that it is weighing the basin floor down by more than half a mile. Peter James, the lead author of the study, described it this way. Imagine taking a pile of metal 5 times larger than the big island of Hawaii and burying it underground. That is roughly how much unexpected mass they detected. There are two possible explanations. One is that the metal core of the asteroid that created the basin is still embedded in the moon's mantle. Computer simulations suggest that under the right conditions, an iron-nickel core could be dispersed into the upper mantle during an impact and remain suspended there for billions of years. The other possibility is that the mass represents a concentration of dense oxides that formed during the final stages of the moon's magma ocean solidification. Either way, it is strange, and it is exactly where China decided to land. Chang'e 4 entered lunar orbit on December 12, 2018. For 3 weeks, it circled the moon, refining its trajectory and preparing for the final approach. The landing was scheduled for early January, but the exact timing was kept secret. Prior to confirmation, many details of the mission had not been disclosed. On January 3, 2019, at approximately 2:30 in the morning, GMT, Chang'e 4 began its descent. Starting from an altitude of 15 kilometers, the spacecraft used a rocket booster to decelerate. This is normal for lunar landings. There is no atmosphere on the moon, so parachutes do not work. You have to burn fuel to slow down. At 100 meters above the surface, the probe briefly hovered. Using a high-tech camera and laser measurements, it scanned the terrain below, identifying obstacles and measuring slopes. The surface of the moon is not smooth. It is covered with rocks, boulders, and impact craters of all sizes. Landing in the wrong spot could mean disaster. Chang'e 4 selected a relatively flat area and resumed its descent. It touched down softly in the von Kármán crater at 2:26 GMT. The first close-up images of the far side began transmitting through Queqiao shortly after. NASA Administrator Jim Bridenstine called it an impressive accomplishment. Martin Weiser, a scientist at the Swedish Institute of Space Physics, said it was uncharted territory, and that made it very exciting. But the landing was only the beginning. After the solar panels and antennas were deployed, Mission Control in Beijing prepared to release the rover. The rover's name is Yutu-2, which means Jade Rabbit in Mandarin. It is the second rover China has sent to the moon. The first, Yutu, landed on the near side in 2013. Yutu-2 is small. It weighs about 140 kilograms and stands roughly 1 meter tall. It moves slowly, traveling at a maximum speed of 200 meters per hour, but it is equipped with sophisticated instruments, a panoramic camera, a ground-penetrating radar, a visible and near-infrared spectrometer, and an advanced small analyzer for neutral atoms. Its mission is simple: drive around, take pictures, analyze the soil and rocks, send everything back to Earth. And then it found something unexpected. In early 2022, scientists analyzing images from Yutu-2 noticed something unusual on the surface. Two translucent glass spheres sitting on the dusty lunar regolith. They were small, between 15 and 25 millimeters in diameter, roughly the size of marbles. But they were different from anything that had been found on the moon before. Glass has been spotted on the moon in the past. The Apollo astronauts brought back samples of it. NASA's Apollo 16 mission found glass chunks near an impact crater on the near side, some as large as 40 millimeters in diameter. But those samples were opaque, dark, solid. The spheres found by Yutu-2 were translucent. You could almost see through them. They glistened against the dry gray landscape like small pearls. Zheng Xiao, a planetary geologist at Sun Yat-sen University and one of the lead scientists on the Chang'e 4 mission, said the globules simply blew their minds. They were so unique on the moon. Glass forms when silicon-rich minerals are rapidly superheated. On the moon, this typically happens during a high-speed impact. When a meteorite strikes the surface, it vaporizes rock. The molten material is thrown into the air, and as it cools in the vacuum of space, it solidifies into glass. Scientists call these microtectites. They have been found on Earth around impact sites. Upon being struck by a meteorite, chunks of planetary crust are thrown up into the air. The molten silicate minerals contained within combine to form tiny glass beads that are sprinkled over the surrounding landscape. The microtectites discovered by Yutu-2 are larger than those typically found on Earth, but they are smaller than the glass chunks found by Apollo 16, and they are transparent. The researchers believe the spheres were made from anorthosite, a feldspar-rich igneous rock that melted and reformed in the immediate aftermath of a meteor collision. Anorthosite is common on the moon's surface, especially in the highlands. But what is interesting is what this discovery suggests about the moon's composition. Zhao described the spheres as the first discovery of macro-sized translucent glass globules on the moon. He said it confirms that lunar anorthosites are excellent raw materials to manufacture glasses with good light-emitting quality. That might not sound significant, but think about what it means for future exploration. At the dawn of constructing human bases on the moon, lunar anorthosites are a promising and widespread resource. If astronauts can produce glass locally, they will not need to transport it from Earth. Windows, lenses, solar panels. All of these could be manufactured on the moon using materials already there. But the glass spheres were not the only discovery. U-22 also detected something in the soil. In 2021, Chinese researchers analyzing samples brought back by the Chang'e 5 mission made an announcement. They had discovered natural fullerene graphene in lunar soil. This was the first time graphene had been confirmed on the moon. Graphene is a form of carbon made up of a single layer of atoms arranged in a honeycomb structure. It was first isolated in 2004 by Andrei Game and Konstantin Novoselov, who later won the Nobel Prize in Physics for the discovery. Graphene is incredibly strong. It conducts electricity better than copper. It is one of the thinnest materials known to exist, and now it has been found on the moon. The samples analyzed came from the Oceanus Procellarum region on the near side, collected by Chang'e 5 in December 2020, but the discovery has implications for the entire moon, including the far side. The researchers used a variety of techniques to confirm the presence of graphene, scanning electron microscopy, Raman spectroscopy, high-resolution transmission electron microscopy. They found graphene embedded as individual flakes ranging from 2 to 7 layers thick. In some cases, the graphene formed a shell structure enclosing a core of complex minerals. This suggests a bottom-up synthesis process. The graphene was not created by exfoliation, where layers are separated from graphite. Instead, it was formed through a high-temperature catalytic reaction. The researchers proposed that the graphene may have been created during volcanic eruptions in the moon's early history, or it could have formed through interactions with the solar wind, which carries high-energy particles that can stir up lunar soil and generate plasma discharge on the surface. Iron-containing minerals such as olivine and pyroxene may have acted as catalysts, helping transform carbon atoms into graphene. Meteorite impacts, which create high-temperature and high-pressure environments, could also have contributed. What makes this discovery significant is what it tells us about the moon's history. For decades, scientists believed the moon was carbon depleted. Samples brought back by the Apollo missions showed that the moon had much less carbon than Earth. This supported the giant impact hypothesis, the theory that the moon formed when a Mars-sized object called Theia collided with Earth about 4.5 billion years ago. The intense heat from the collision would have vaporized volatile elements, including carbon, leaving behind a carbon-poor body. But the discovery of graphene, along with recent observations of carbon ion fluxes emanating from the moon, suggests there may be indigenous carbon present. That challenges the existing consensus. Wei Chang, a professor at Jilin University and one of the lead researchers, said the finding may reinvent the understanding of chemical components, geographic episodes, and the history of the moon. It also opens up new possibilities for lunar exploration. If graphene is abundant on the moon, it could be used to manufacture advanced materials for future bases. Electronics, sensors, energy storage devices, all of these could potentially be produced using lunar resources. But there is more. In 2024, another team of Chinese researchers announced they had discovered something even more unusual in samples from the far side: single-walled carbon nanotubes. Carbon nanotubes are cylindrical structures made of rolled-up sheets of graphene. They are incredibly strong and lightweight. They conduct electricity and heat extremely well. Until recently, carbon nanotubes were thought to require artificial preparation. They have been synthesized in laboratories for decades, but finding them in nature is extremely rare. The discovery came from samples collected by the Chang'e 6 mission, which launched on May 3, 2024. Chang'e 6 was China's second sample return mission, following Chang'e 5. But this time, the target was the far side. Chang'e 6 landed in the Apollo Basin, a large crater within the South Pole-Aitken Basin, on June 1, 2024. It collected samples from the surface and returned them to Earth on June 25. The samples were analyzed using multiple spectroscopy and microscopy techniques. The researchers identified single-walled carbon nanotubes formed through micrometeorite impacts and an iron-driven catalysis process. The formation likely occurred under early volcanic activities and solar wind irradiation on the lunar surface. This is significant for several reasons. First, it demonstrates that carbon nanotubes can form naturally. They are not just laboratory creations. They exist in nature, shaped by cosmic processes. Second, it provides additional evidence of indigenous carbon on the moon. The presence of both graphene and carbon nanotubes suggests that carbon is more abundant on the moon than previously thought. And third, it challenges the idea that the moon is a dead, unchanging world. The moon has a history, volcanic eruptions, solar wind interactions, meteorite impacts. All of these processes have shaped its surface and created complex materials over billions of years. But perhaps the most intriguing discovery from the far side has nothing to do with carbon. It has to do with the moon's origin. The moon is thought to have formed about 4.5 billion years ago when a Mars-sized object collided with the young Earth. This object has been named Theia, after the mythical Greek Titan who was the mother of Selene, the goddess of the moon. The collision was catastrophic. Both Theia and the proto-Earth were turned into molten lava. Most of Theia's iron core sank into Earth's core, but a significant portion of the mantle material from both bodies was ejected into orbit around Earth. Over time, this debris coalesced and cooled to form the moon. This is called the giant impact hypothesis, and it is currently the favored explanation for the moon's formation among astronomers. Evidence for the hypothesis includes the fact that the moon's orbit has a similar orientation to Earth's rotation. The stable isotope ratios of lunar and terrestrial rock are nearly identical, suggesting a common origin, and the Earth-Moon system contains an unusually high amount of angular momentum compared to other terrestrial planets. But there are problems. One of the biggest is the moon's composition. If the moon formed primarily from Theia, as most models suggest, then it should have a different isotopic signature than Earth. Theia would have formed in a different part of the solar system, where the building materials were slightly different. But the moon's oxygen isotopes are essentially identical to Earth's. So are its titanium isotopes and its iron isotopes. This does not make sense unless Theia and Earth formed in the same neighborhood. In November 2025, a team of researchers led by Timo Hopp from the Max Planck Institute for Solar System Research published a study in the journal Science. They examined the ratio of different iron isotopes in Earth and moon rocks with unprecedented precision. They analyzed 15 terrestrial rocks and 6 lunar samples brought back by the Apollo missions. The results confirmed what earlier studies had shown. Earth and the moon are indistinguishable in their iron isotopic composition, but the team went further. They used mass balance calculations to model different collision scenarios, testing various compositions and sizes for Theia and the proto-Earth. Their conclusion was striking. The most convincing scenario is that most of the building blocks of Earth and Theia originated in the inner solar system. Earth and Theia were likely neighbors. Theia probably formed closer to the Sun than Earth, not in the outer solar system, as some theories had suggested. This has implications for understanding the early solar system. It suggests that planetary collisions were not random events involving bodies from vastly different regions. Instead, they were collisions between neighbors, objects that formed in similar environments from similar materials. And it might explain why Earth and the moon are so similar, but it also raises new questions. If Theia and Earth were neighbors, why did they collide? What caused Theia to leave its stable orbit and crash into Earth? One possibility is that Theia formed at a Lagrange point in Earth's orbit, similar to where Queqiao sits today. Lagrange points are stable, but only up to a certain mass. Once Theia grew large enough, gravitational perturbations from other planets could have destabilized its orbit, sending it on a collision course with Earth. Another possibility is that a second collision occurred earlier, setting Theia spinning fast enough to alter its trajectory. We may never know for certain, but what we do know is that the collision changed everything. It gave Earth its moon. It tilted Earth's axis, creating seasons. It sped up Earth's rotation, shortening the length of a day, and it may have created the conditions necessary for life. The South Pole-Aitken Basin is not just the largest impact structure on the moon, it is also one of the oldest. Radiometric dating of lunar zircons suggests the basin formed approximately 4.338 billion years ago, during a period known as the pre-Nectarian epoch. This was a time of heavy bombardment in the inner solar system. Asteroids and comets left over from the formation of the planets were still crashing into everything in sight. Earth was bombarded too, but unlike the moon, Earth has active geological processes: plate tectonics, erosion, volcanism. These processes erase the evidence of ancient impacts. The moon, on the other hand, is geologically quiet. Its surface changes slowly. Impact craters from billions of years ago are still visible. This makes the moon a kind of archive, a record of what the early solar system was like. Understanding the timing and intensity of the bombardment is important. That was going on about the same time that life appeared on Earth. Scientists are trying to work out the exact sequence. Did the bombardment create the conditions for life? Or did life emerge despite the bombardment? The Earth has lost its record of that very early time, but the moon has not. Dating when the South Pole-Aitken Basin was created could help narrow down the window for the period of heavy bombardment, and that could help us understand when and how life began. This is why the basin is such a scientifically significant location, and it is why China keeps going back. On March 20th, 2024, China launched a new relay satellite called Queqiao 2. The original Queqiao satellite had exceeded its designed lifespan. Queqiao 2 was built to take over communications relay services for Chang'e 4, which is still operating on the far side, and to support future missions. Compared to the first Queqiao satellite, Queqiao 2 has enhanced functionality, innovative features, and more intricate designs. It also carries multiple instruments for scientific exploration. The deployment of Queqiao 2 is a key step for China's future lunar exploration missions, including Chang'e 7 and Chang'e 8. Chang'e 7 is scheduled to launch around 2026. Chang'e 8 will follow around 2028. Together, they will form the basic model of a lunar research station to carry out lunar environment exploration. But before that, there was Chang'e 6. On May 3, 2024, Chang'e 6 launched from the Wenchang Space Launch Center. Its mission was to collect samples from the far side and return them to Earth. It was the first sample return mission from the far side of the moon. On June 1, 2024, at 22:23 UTC, Chang'e 6 touched down in the Apollo Basin, located within the South Pole-Aitken Basin. The lander deployed a small rover called Jinshan to conduct infrared spectroscopy of the lunar surface and photograph the lander. On June 3, at 23:38 UTC, the ascender launched back to lunar orbit, carrying samples collected by the lander. It completed a robotic rendezvous and docking in lunar orbit, transferring the sample container to the returner. On June 25, 2024, the returner landed in Inner Mongolia, completing China's far-side sample return mission. The samples are now being analyzed, and what they contain could change everything. Let us step back and review what China has discovered on the far side of the moon. Translucent glass spheres formed by ancient meteor impacts, evidence that lunar anorthosites can be used to manufacture high-quality glass. Natural graphene embedded in the soil, the first confirmation that this wonder material exists on the moon. Single-walled carbon nanotubes formed through micrometeorite impacts and iron-driven catalysis. Evidence of complex chemical processes occurring on the lunar surface over billions of years, and samples from the oldest, deepest impact basin in the solar system, containing material that may have come from the moon's mantle. All of this information is helping scientists understand the moon's formation, its geological history, and its potential as a resource for future exploration. But there is something else. Something that has not been fully explained. In May 2019, scientists announced the discovery of a large mass of material deep within the South Pole-Aitken Basin, a concentration of density so extreme that it is pulling the crater floor downward. The leading theory is that it is the metal core of the asteroid that created the basin, still embedded in the moon's mantle after 4 billion years. But that is just a theory. Another possibility is that the mass represents a concentration of dense oxides formed during the moon's magma ocean solidification, or it could be something else entirely. China has now landed in that basin 3 times: Chang'e 4, Chang'e 6, and potentially Chang'e 7 in the near future. They have collected samples, they have analyzed the soil, they have mapped the terrain, and so far, they have not said what they think the anomaly is. That does not mean they are hiding anything. It means the data is still being analyzed. Science takes time. but it does raise questions. What if the anomaly is not just metal from an asteroid? What if it is something more complex? What if the collision that created the South Pole-Aitken Basin exposed material from deep within the moon's interior? Material that tells a different story about how the moon formed. What if the moon is not quite what we think it is? There is another puzzle about the moon that scientists have been trying to solve for decades. The two sides of the moon look completely different. The near side, the one we can see from Earth, is covered with dark maria. These are vast plains of solidified lava that filled ancient impact basins billions of years ago. The far side has very few maria. Instead, it is heavily cratered, with thicker crust and a more rugged appearance. Scientists have wondered about this asymmetry for years. Why are the two sides so different? One theory is that the South Pole-Aitken impact is responsible. The collision would have added a tremendous amount of energy to the moon's interior processes. The flood of heat could have concentrated heat-generating and rare earth elements on the moon's near side, producing a prolonged volcanic environment that created the vast plains of magma. This would explain why the near side has so many maria while the far side does not. But there is another theory. In 2011, researchers suggested that a second, smaller moon may have formed alongside our moon during the giant impact. This smaller moon, about 1,000 kilometers in diameter, would have remained in orbit for tens of millions of years before slowly colliding with the far side. The collision would have been at a low enough velocity that it did not form a crater. Instead, the material from the smaller moon would have spread across the far side, adding a thick layer of crust. This would explain why the far side's crust is so much thicker than the near side's. However, mapping by the Grail mission has ruled out this scenario. The data does not support the existence of a second moon, so the mystery remains. Why are the two sides of the moon so different? What process created this asymmetry? The answer may lie buried beneath the South Pole-Aitken Basin, and China may be the first to find it. Here is where the story takes its strangest turn yet. The James Webb Space Telescope was scheduled for a follow-up observation of the Chang'e 6 landing site just days after the samples were collected. The observation was aborted. The official reason was a focus lock refusal. Let me explain what that means. Webb has sophisticated tracking software that allows it to lock onto distant objects and follow them as they move across the sky. This system has worked flawlessly on countless targets: stars, galaxies, nebulae, asteroids, comets. The telescope points where you tell it to point. Except this time, it did not. The software refused to lock onto the Chang'e 6 landing site. Engineers were baffled. There was no technical malfunction, no hardware failure. The telescope simply would not aim at this particular location. Some people joked that it was as if the telescope made a choice, but nobody could explain why the tracking system behaved this way. Around the same time, amateur astronomers reported seeing brief flashes in the region of the moon where Chang'e 6 had landed. Not steady light. Not the normal reflection of sunlight. Quick, rhythmic flashes that appeared almost deliberate. One observer described it as looking like a camera flash pointed in our direction. If you have an active imagination, you might wonder if something at the landing site somehow knew it was being watched, if it had some way of detecting our telescopes and responding to them. But that is getting into territory that most scientists are not comfortable exploring publicly. What we can say for certain is that the behavior surrounding the Chang'e 6 mission defies easy explanation at almost every turn. Now, about that leaked image itself. The one that started this whole discussion. It turns out the image was never supposed to be released. It was not part of any scheduled observation. It was not cleared through normal channels at the China National Space Administration. The metadata shows it came from a remote operations session, an automated backup image captured during a diagnostic sweep, the kind of image that is usually deleted or archived without anyone ever looking at it. So how did it get out? Some believe a whistleblower inside the Chang'e program deliberately leaked it. Others suggest it might have been a cyber intrusion, someone hacking into the system and pulling files that were supposed to stay hidden. There is even a more exotic theory floating around, that the leak was somehow intentional but not on our end, that we were meant to see this image, that it was not a mistake but a message. That last idea sounds like science fiction, and maybe it is. But when you are dealing with discoveries this strange, it becomes harder to dismiss any possibility entirely. After the Chang'e 6 samples were returned, monitoring stations around the world started reporting unusual problems. Spectrometers used to analyze light from the moon failed to calibrate properly. Gyroscopes in both ground-based and space-based telescopes began drifting out of synchronization. Radio signals sent toward the region of the moon where Chang'e 6 had landed bounced back in unpredictable ways. It was not just standard electromagnetic interference. Scientists described it as a zone of disruption, as if something in that area of the moon was affecting instruments in ways they could not explain. Then satellites started having problems. Small CubeSats designed to monitor lunar activity began going dark as they passed near the projected path of the Chang'e missions. Not all of them, but enough to notice a pattern. Engineers could not find any common cause for the failures. Some researchers speculated that something near the landing site might be absorbing energy rather than emitting it, as if the area was not just a passive location, but something more active, something feeding on the electromagnetic environment around it. A small team of data analysts decided to look more closely at the telemetry from Chang'e 6's instruments. They found something hidden in what everyone else had dismissed as noise, fluctuations in the return signal that formed repeating patterns. When they translated these patterns into binary and compared them to known structures, something unexpected emerged. The patterns resembled sequences found in RNA, the molecular instructions that living things use to build proteins and carry out biological functions. This was not communication in any traditional sense. It was not a message written in words or symbols. It was information encoded at a much deeper level. Information that would only make sense to something capable of understanding biochemistry. One scientist called it a biogenic algorithm, a sequence that, if replicated, might trigger some process in organic matter. Some researchers whispered that it looked like activation code. Others went further, suggesting it might be a blueprint, a genetic catalyst for something we cannot yet imagine. Think about what that means. If the South Pole-Aitken Basin is carrying genetic information, if it is broadcasting sequences that could affect biological systems, then it is not just a geological feature, it is a seed ship. A vessel designed to spread life, or at least the instructions for life, across the cosmos. This is panspermia, the idea that life does not originate independently on each planet, but is seeded from space, and the South Pole-Aitken Basin might be the mechanism, the delivery system, the cosmic FedEx truck carrying the blueprints for life from one world to another. And then, just as scientists were beginning to make sense of what they were seeing, something strange happened. Observatories tracking the Chang'e 6 landing site reported unusual changes in the reflected light from the area. The spectral signature shifted, the albedo changed, the surface appeared to be transforming. And then, for a brief period, the entire landing site disappeared from radar. Some astronomers suggested it had simply moved into shadow, where instruments could not observe it. Others wondered if something had activated, a mechanism, a process, something that changed the nature of the surface itself. Just before the disappearance, sensors recorded a final burst of electromagnetic activity, 13 pulses, evenly spaced. Some people tried to interpret them as Morse code, but no alphabet seemed to fit. Then a linguist suggested looking at it differently, not as language, but as numbers. A countdown. If you are counting down, you are counting toward something, and we have no idea what that something might be. While the scientific community debated what the pulses meant, another piece of information surfaced on encrypted forums. Documents allegedly pulled from internal Chinese space agency servers suggested that the South Pole-Aitken Basin was not unique. There are similar mass anomalies on other bodies in the solar system: Mars, Europa, Titan. According to these leaked documents, all of these anomalies share similar characteristics: unusual density, gravitational perturbations, electromagnetic signatures that do not match natural geological processes. Most disturbing was a phrase that appeared multiple times in the documents, highlighted in red: seeding phase complete. If these leaks are accurate, we are not looking at isolated events. We are looking at a pattern, a mission, and the South Pole-Aitken Basin was never the final location. It was one node in a network. Let us talk about what it means if any of this is true. What it means if the South Pole-Aitken Basin really is something more than a natural impact crater. First, it means we are not alone. It means there is another intelligence out there, somewhere in the cosmos, that has the capability to seed worlds with the building blocks of life. Second, it means they are interested in us. They did not just seed random worlds, they seeded Earth's moon. They placed something in our cosmic backyard. Why? What is special about us? Maybe they detected our biosphere. Maybe they saw the oxygen in our atmosphere, the signature of photosynthetic life, and they wanted to investigate. Or maybe they have been watching us for much longer. Maybe the mass anomaly has been in the South Pole-Aitken Basin for billions of years, observing Earth, waiting for us to reach a certain level of development. And maybe now, with China landing directly above it, with us finally reaching the far side of the moon, we have triggered something. We have activated the next phase. Whatever that phase is. Third, it means we have to prepare. We have to decide how we are going to respond. Do we continue exploring? Do we send more missions to the South Pole-Aitken Basin? Do we try to excavate the mass anomaly and see what it really is? Or do we leave it alone? Do we back away and pretend we never saw anything? These are questions that humanity has never had to answer before. These are decisions that will shape the future of our species. So what happens next? Where do we go from here? China is not done with the far side. Chang'e 7 and Chang'e 8 are just the beginning. Plans for a permanent lunar research station are already underway, and China is not alone. The United States, Russia, India, Japan, all are planning missions to the moon in the coming years. The far side, once the most inaccessible place in the solar system, is about to become one of the most visited, and with each mission, we will learn more. We will collect more samples. We will analyze more rocks. We will map the terrain in higher resolution. We will drill deeper into the surface. We will study the mass anomaly beneath the South Pole-Aitken Basin. We will search for clues about the moon's formation and the collision that created it. We will look for evidence of indigenous carbon. We will test new technologies. We will prepare for the day when humans return to the moon to stay. And maybe, just maybe, we will find something we did not expect. Something that changes everything. Because that is what exploration is about. Not finding what you are looking for, but being ready for what you find. So what did China find on the dark side of the moon? They found glass spheres formed by ancient meteor impacts. Evidence that the moon's surface is rich in materials that could be used to build future habitats. They found natural graphene and carbon nanotubes. Proof that complex chemical processes are still occurring on the lunar surface billions of years after its formation. They found rocks from the oldest impact basin in the solar system, samples that may contain material from the moon's mantle and reveal secrets about its origin. And they found a mystery, a massive concentration of material buried deep beneath the surface, an anomaly so dense it is dragging the crater floor downward. An anomaly that might be the metal core of an ancient asteroid, or something else entirely. We do not know yet, but we will, because the far side of the moon is no longer hidden from us. We have landed there, we have explored it, we have collected samples and brought them home, and we are going back. The signal did not cut, the discoveries are real, and the journey is just beginning. For now, all we can do is watch the data come in, study the samples, build our models, test our theories, and wait for the next mission. Because every time we think we understand the moon, it surprises us. Every answer brings another question, and that is how science moves forward, one discovery at a time. The moon is waiting, and so are we. Thank you for watching, and remember, the universe is vast, the cosmos is ancient, and we are just beginning to understand our place in it. What China found on the dark side of the moon may be the most important discovery we have ever made, or it may be just the beginning.